Hi friends, hope you have seen the previous videos in machine learning, and in this video we are going to discuss about artificial neural network. So it is actually present in your unity, and these are the topics which were covered in the third unit, and in that we are going to look into the first topic, that is the artificial neural networks. So first of all, we want to know the basics of artificial neural networks. So what is artificial neural networks, or how this particular term is coined? So that we need to see first. So what is the major inspiration of creating this artificial neural network is the human brain. So this human brain which works 24 hours, which is the process by which this human brain is working. So that is the major inspiration for creating this artificial neural networks, or we call it as AND. So human brain, it consists of a number of neurons. Those are interconnected to each other, that we know. Similarly, in this AND, it also contains interconnected neurons which are interconnected to each other through various layers of the networks. We call those neurons in this artificial network as nodes. So this artificial neural network, it's similar to this human brain. It also contains various neurons connected to one another in various layers of the networks. Those neurons we are calling, or we are using the name nodes in this AND. So what is this neural network? It is the set of algorithm which is used to recognize the patterns or the relationships and the information that are available from the huge volume of data present. So from that huge volume of data, you are going to extract or recognize the patterns, relationships and the information. So those the algorithm which does this particular process, you call it as neural networks. What are all the components that are present in the artificial neural networks that we are going to see now? So what are the components? There is input layer, hidden layer and output layer. These are the three important components which are available in this artificial neural network. So in this diagram, you could see that the first layer from the left, the first layer is the input layer, which is marked using the yellow. So this layer is specifically meant for getting the input from the outside world. So this is the input layer, and the next at the end, at the rightmost end, the pink color, that is the output layer, which is specifically meant for producing or displaying the output. The intermediate layers between this input layer and the output layers, you call it as the hidden layers. Those are present inside. So these are the different layers that are available in the artificial neural networks. So those layers we are going to see one by one. First is the input layer. So this input layer is meant for accepting the input from the outside world. And the second is the hidden layer. As I said, that hidden layer may be a single or multiple. Any number of hidden layers may be present. So what is the purpose of this hidden layer? Hidden layer is a set of neurons which performs all computations on the input data. So the input layer will be getting the input. This hidden layer will be processing those input and performing all the computations. So this layer may contain any number of hidden layers. And the third layer is the output layer. As I said already, this displays the output of the computations that are done by this hidden layer. So these output layer can be having a single node or a multiple node. If you are going for performing some binary classification, you could be using a single node output. For binary classification, it is enough for us to have a single node output. If we are going for some multi-level classification, so then there will be a need for having more than one node. So at that time you need to use more than one node in this output layer. So based on the requirement, you could have the number of nodes that are available in the output layer. So next concept which is available in this artificial neural network, and the important concept is perceptron. What is this perceptron is? It is the simple form of neural network as displayed in this diagram. This is a very simple form of neural network which has the input, and this is the node, the blue color circle, this denotes the node. So there will be only single node or the single layer which performs all the mathematical computations. So perceptron is the simple form of the neural network which consists of a single layer where all the mathematical computations are performed. The next thing available here is multi-layer perceptron. Okay, this is actually the artificial neural network. So that is what mentioned here, multi-layer perceptron or artificial neural network. So it contains more than one perceptron, or it contains more than one perception which is grouped together to form a multi-layer neural network. So this example which is shown here, this is an example for the multi-layer neural network. So here you could see there are different number of perceptrons, there are different nodes, number of nodes are available, and that does the process whatever initialized for that. So such type of network, we call it as multi-layer perceptron or artificial neural network. How this neural network, that is how this artificial neural network works, that we are going to see now. So just to get into this particular diagram which is mentioned here. So here you have different input values, x1, x2, x3 up to xn. All these denotes the various inputs that are available. And this W1, W2, W3, these denotes the weights of connection, or what is the weightage you are going to give for this particular input, that is the weights of connection. And one more input what we are giving is the bias value. Okay, it is a constant which you are giving. This is the bias value. This also you will be adding as a input here. Okay. And this blue is a node which performs the operation whatever it is going to do. Okay. What it does is the formula, it's mentioned here, this is the summer unit which calculates the sum of this x1 into y1, and it adds the value with the bias value. So these things let us see one by one, step by step. So the first step is all the inputs are multiplied with their weights. So you are going to multiply x1 with y1, x2 with y2, x3 with y3, etc. So this you are going to do in your first step. So you will be multiplying all those inputs with their weights. And the next thing what you are going to do is you are going to add a bias value. What is this bias value? It is a constant which helps the model to fit in the best way possible. So that is the major objective of using this bias value. So when these values are being calculated, now it is easy for you to calculate the value of Z1 using this particular formula. So Z1 is equal to the summation of all those multiples that we have, the products what we have get by multiplying their input and the weights. So once this value is being calculated, now we can move to the step 2. The step 2, what you are going to do is you are going to apply the activation function to a C1. What is this activation function? This activation function is a non-linear transformation that is applied to the input before sending it to the next layer of mirror. So this activation function is the non-linear transformation that you are going to apply over this input or the product which is available before you are sending it to the next layer or the output layer. And let us move to the next step. The third step is computation of result. It is passed to the output. So we have calculated the summary units, we have calculated or we have put the activation function, and now we are going to display the computation results to the outside world. So this is the major objective of this output layer, and this is done in the third step. So when coming this way, from getting the input, processing the input, generating the output and displaying the output. So this is a process, and this is called as forward propagation. So this artificial neural network, it works based on this forward propagation. Okay. And next we are going to look into the thing that is the back propagation. When you have obtained your output, now you are going to compare the output which you have obtained, or the predicted output you are going to compare with the actual output. And if there is some error in calculation, if it is a small error, then we can omit it. If the error is very large, what you could do is you need to go back. So you are going to go back or make some necessary changes in the weights, or you can make changes in the bias value to minimize the error. So you are going back. So this process of going back from the predicted output to the input, that we call as back propagation. So let's look into the definition again. So this back propagation is updating and finding the optimal value of weights or coefficients to minimize the error. So now after getting the output, you are going to look back to this input values and you are going to update it to get the optimal value. So for updating these weights, you are going to use a term called, or you are going to use a particular thing, that is the optimizer. So what is this optimizer is? It is a method or mathematical formulation which is used to change the attributes. So these are some of the characteristics of the back propagation. So first one is the instances of this back propagation are represented by many attribute value pairs, and the target functions or the output, it may be a discrete value or real value, or it may be a vector of several real or discrete valued attributes. So this is the second characteristics. The third one is The training example may contain error that may not affect your execution. And the third is long training times are acceptable. So large number of training time may be consumed, that is not a problem in case of this back propagation. And fast evaluation of learned target function may be required. So once the function is being learned, then it should be evaluated so quickly. And the ability of the humans to understand the learned target function is not important. So the human may or may not be understanding it. It is not a problem, because anyway we are going to migrate or going back to execute our program or minimize the error. And when considering the types of this artificial neural networks, there are two types of artificial neural networks. One is feed forward and feedback and. So let us look into this one by one. The first is the feed forward and. So this, in the feed forward and, the flow of information, it will be in only one direction. And mostly in supervised learning you will be using this feed forward and, because from the training data you are going to learn and you are going to predict. Okay, so mostly in the supervised learning you will be using this feed forward and, where the flow of information takes place in only one direction. And the next type of artificial neural network is feedback and, where there will be a feedback loop available. So you will be getting an output, you are going to compare the output, and if there is a need for any change you are going to get back to the thing. So it is most suited for areas where the data is sequential or time dependent, because based on the feedback you may be going back and getting the input coming again. So this may happen. So it is more suited for areas where the data is sequential or time dependent. So hope you have understood what are the things we have discussed. Post your queries. Thank you.